All right, and we are recording. Awesome. Let's get started here. So yes, Schitt's Creek. I love that show. I've watched all the seasons now. Just caught up. It did save me during the pandemic. Oh, it's paused. There we go. All right. So yeah, today, Thursday. Hope everyone's having a great day. End of the week. Friday is almost here, so hold on tight. We're going to finish up this Thursday talking about inheritance. Before we dive into that, of course, we always got to go with announcements. The first announcement I have is that assignment number 2 is right around the corner. So hopefully everyone has at least read the assignment. At the very, very least, make sure you open up the assignment and see what you're getting yourself into. At the far end, maybe you've already finished it or at least working on it as well. So just know the due date is right around the corner. Hopefully, at least it's open. Leading back to number 1, assignment number 1, don't forget, finish this up as soon as you can. You don't want to get all those assignments on your plate, so at the very end of unit 1 or unit 2, you're going to have to go back and do all those assignments. So make sure that they're getting done as well as they can on time. So if you haven't finished up number 1, reach out to your TAs, reach out to me, reach out to a fellow student to get any questions you have answered about it so we can get it across the line. Let me know if my headphones have been pretty weird lately. So if I'm going in and out or if I sound like I'm in a hallway, just call me out for it and I'll see what I can do. But everybody thumbs up on this? Everybody can hear me all right?
Oh yeah, we hear you just fine.
Oh, good.
All right, fantastic. I'm sure my neighbors hate me because I'm yelling at a wall right now that's pretty much into their living room like every Monday and Thursday. I'm waiting for them to knock on my door. Okay, let's get started here. Before we dive into inheritance, we're going to go and talk about something we talked about a few weeks ago. We're going to talk about maps. Going into an example, if we wanted to create a data structure that contains pet names and associated IDs all within it, from that sentence I said before, I already gave the hint, we're going to need a hash map for this. Breaking down this ask, or this task that's presented to us, looking in the sentence, it says pet names and associated IDs. Pet names, associated IDs. To create a hash map, what are the 2 things that we need?
Key and a value.
Key and a value. Yep.
Key and a value. I like that. Let's start at the key. Keys, giving it a small hint, they have to be unique. So in that sentence, pet names and IDs, which one would be our key?
ID.
IDs, very good. Going back over to our value, obviously, that would be what now? What will be our values in this hash map?
Pet name.
The
Pet names.
Very good. I mean, it can be whatever. So IDs in this instance are going to be integers, and pet names are typically what kind of data type?
String.
String.
Very good. So let's moving on to building our actual hash map of this. We have our hash map, and then we have our pointy brackets. I've heard some people call them carets, just brackets, but I refer to them as those pointy brackets. So within here, we need to move integer and string to tell it where our keys and or what data type our keys and our values are going to be. On the left-hand side of that comma, would it be integer or string?
Integer. String.
We're going to put the data type of our key, which is integer, on the left-hand side, and string, which is pet names, the data type of our pet names, on the right-hand side. To tell our hash map, our values will be strings, but our keys will be integers. So, using this example, let's move on. Any questions about this so far? I don't have much. All right. Most of this should be relatively, or something that you've seen before, relatively familiar. I'm looking for words today. So here's our hash map of example. Let's do another task. Let's say we wanted to add Stark to my pet shop with the ID of 1. How would I begin to do this?
mypetshop.add.
mypetshop.put.
.put, very good.
Put,
And
okay.
how would we set up our parameters?
So it will be 1 and then name will be Stark.
Very good. The first parameter of put is the key, and the second parameter is the value. Always remember that put is how we add something to a hash map. add is for array lists. Moving on. Same thing with Bell. We're going to add Bell, which is a cat, or our cat's name in our past lectures, for the ID of 2. So again, how do we do that?
My pet shop.
My pet shop with dot put 2 comma
Very
Bell.
good. We put 2 comma Bell. And then finally, how do we get Stark after we added these 2 different pet names into our hash map? How do we get Stark out of my pet shop?
So it will be my pet shop dot get, and we can put in brackets 1.
Very good. In those parentheses, we're going to put the number 1 because 1 is associated with Stark. As we see on our first put example, 1 is the key to unlock our value out of the hash map. Diving a little bit more into this. How can I get all of the keys from my hash map? Those keys again would be 1 and 2 in this example. But what do we do? How do we call to all those keys? How do we get all those keys from the hash map?
My pet shop dot get keys. Parentheses.
Close. It's close. It's not essentially dot keys, but one more word attached to that.
Oh, you said get key.
Get key. Key value.
Key value.
Get
It would be
value.
dot key set.
Key set. Oh.
Key set. This is how we get our set of keys.
Oh, of course. Okay.
But I liked all the guesses too. Java can be pretty, well, you can probably usually guess what their names are going to be. Their naming conventions try to be as similar as possible. So get keys or keys, that could also be very good guesses. But in this case, for hash maps, to get all those keys, we use dot key set. So our final task here, how can we print each of the values in a hash map?
Loop it.
I like that. Well, let's start looping it.
That.
So we have a loop. What would be on the right side of the colon here? How do we start to try to get the value?
Value.
So values doesn't actually exist in hash map. That small hint we have there, you need a key to unlock a value out of a hash map. That's it. That's the one law hash maps have. You have to have the key. You can't just grab the values.
Oh, for key of key set. Oh, for key of my pet shop dot key set.
Very good. Absolutely. This is how we would start looping through our keys. The first step of getting those values out. So integer key, because remember in our hash map, our keys are integers, and then we call to that key set. Then to print out each value, we have to do what we did on our last example. We have to dot get using that key. So this example here would print out every single value, which would be Stark and Bell, to our screen. So I know that hash maps might have been a slight fun challenge in our assignment 1, and also will be in assignment 2. So any questions about hash maps and how we did this? Anything at all? Why it is the way it is? Why hash maps are even around? Why we even like hash maps? Why are they so mean to us? Anything? No?
Hash maps are awesome.
You say awesome,
Yes, I like hash maps.
right? Aren't they fun? I love hash maps. They're like objects, and you get to store cool stuff in them. And I don't know, but I'm also a nerd, so. All right. Well, so if there's no questions about hash maps, we're going to move on to inheritance. So inheritance makes me think of family, which makes me think of Schitt's Creek for some reason, which makes me put that meme out there. But let's go back to family. In the far maskless future, say we're at a family reunion, and we're gathered by all of our families again without those dang masks and everything, and grandpa's happy and grandma's happy, whatever. And one of the grandkids comes up to grandma or grandpa and asks the question, how did I get my blue eyes? Or just anything like a child would ask, like, why do I have this? Blue eyes, essentially. Well, grandpa or grandma's gonna sit down and start a very long story. And it always starts out with, well, back in my day, and this is how our family is set up. He or she would basically go through the entire lineage of the family saying, oh, well, I was this, and we had your mom, or we had your dad, and then they had you. And basically they would build this giant family tree. Even though you didn't really ask for the entire ancestry, or just kind of asking a question, they're going to tell you all about your family's history. And then your grandma or grandfather is going to say, well, I have blue eyes, so your mom or dad has blue eyes, and therefore you have blue eyes. And you're going to be like, I shouldn't have asked this question because I only wanted to say hi and why do I have blue eyes and get a piece of cheesecake and go back to under the tree because I'm just kind of bored at the family reunion. But you got this whole giant story from your grandma or grandpa about how you got blue eyes. So your grandma or grandfather had them, and it was all passed down. Well, a word that will come up during this story with your relative would probably be inherited. Your blue eyes were inherited on the way down. So why am I going through this giant example of being inherited? Because this is how inheritance is going to look. Not necessarily like this, and you probably are also asking, why are you going through this example like this? So instead of just keep going on this family reunion like tree thing, let's look at a quick next example. Bringing in that family tree that we were just looking at the last slide. And say instead of looking at a family tree, let's look at more of a taxonomy or draw out an animal's family tree. That being said, at the very top of this tree, let's say it's an animal. We can then build off this animal's family tree by getting more specific. Say an animal can be a pet, and then a pet could be a dog. Maybe another dog that's attached to pet, or another pet that's attached to pet is a cat. Attached to animals then, we can also say wild animals. And then inside of that, we can say fox, because foxes are wild animals. Here, we kind of built now a relationship or a family tree of these different classes we've seen between lectures. Starting at animal at the very top of the hierarchy and working its way down into smaller or more and more specific classes, such as dog, cat, and fox. Looking a little bit more into it, kind of bringing in what we said about the blue eyes, what if animal has the method make sound? Well, just like blue eyes, it gets inherited to all the children. So pet and wild will get make sound, dog, cat, and fox would get make sound. All of that's passed down. And it's passed down from what we call the parent class or the base class. Then we pass it down to the child class, and that passes it down to its child class. The way we pass down make sound from the parent class or the base class down to its children, this is what we refer to as inheritance. That's what this word means when we're talking about it in the context of programming. That was not supposed to be a dramatic pause. I just really want a coffee. So this is inheritance at its very high level. However, I'm getting a lot of silence here. So if you have any questions, please feel free to speak up. But I feel like I haven't truly sold you just yet on this idea. So let's take a closer look at some real world examples. So say you wanted to create a video game in Java or whatever. And so in this video game, you're going to have a character. But characters can sometimes be on different teams, such as like a red team and a blue team. Maybe on those red and blue teams, you have different types of characters that have different abilities. Maybe the good guys are able to wield something different. Maybe the bad guys have a different spell. Maybe the red team and the blue team has elves and humans on the red team versus the blue team is orcs and dwarfs, and they all have specific characteristics in them. This is one way you can build a class hierarchy or show inheritance starting at the character class, that base class or parent class, and working its way down into children. So this would be one real world example you would do in kind of a video game. Another example would be, what if you wanted to create a parking app? Well, you start with a vehicle. So maybe break it down into bikes and cars. Maybe they're charged at different prices on your app. Maybe pedal bikes and motorbikes are charged even more different amounts on your app. Same with car. You can break that down into electric cars and gas cars. Maybe electric cars cost a different amount to park in your spot than gas cars. So this is how you can break down a very general term such as character, vehicle, animal into more definitive or specific classes to provide more specific characteristics or properties. Whew, so that was very... technically, yes. If I was looking specifically at the red team, so the question was, would you refer to red team and the blue team as a base class? In reference to elf or human, orc or dwarf, technically red team or blue team would be referred to as a base class. It's its parent class. That's what it's stemming from. So I personally would refer to it as that, red team and blue team. Would red team and blue team both be a parent and a child class? Yes, exactly, because you are a child of somebody, but you also might be a parent of somebody as well. That's how lineage or our hierarchies work, especially in family trees. Very good question. So yes, you can be a parent and you can be a child. Awesome questions.
I mean, technically, every class is a child of the object class, right?
Well, we haven't gotten to that yet, but I will say you are correct. Very good. But yeah, you're absolutely correct on that. Any other questions too? All right. Well, you're probably asking yourself then at this point that I've just shown you a bunch of diagrams. What do they mean? So let's start diving into what this actually, how we can actually get into this. So we're going to look at just a very specific branch of our example, which is pet, and a pet is a dog. It's the only hierarchy we're going to be looking at. So we're going to start at pet. So if I wanted to create the class pet, I just say public class pet. I give it a name, I give it a constructor, and I do a getter for the name. Nothing here has changed. There's nothing new. You've seen this before. So let's move down to dog. Dog stems from pet. Pet is its parent class. So to begin writing this, we'd write it just typical, public class dog. And then we would say it extends pet. It extends its parent. We use this keyword extends here to truly tell our compiler, hey, pet is my parent. I want you to bring in everything from pet into my dog class. Everything that's public will then be brought into my dog class. Public and protected properties and methods will be brought into the dog class. That's what extends is doing, essentially, in Java. Moving a little bit forward, let's say we need to then create a constructor. Yes.
Kyle, sorry to interrupt. Can you repeat that one more time, please?
For sure. So the word extends, when we put it into our dog class, that extends pet, pet is its parent class. Essentially, what extends means is it brings in everything from the pet class and passes it into dog. So what am I saying by that? That means this getter, this public string get name, is now part of dog. This constructor can now be accessed by dog. Everything that's public or protected in pet will be passed down to dog. Basically inherited by dog. Does that kind of help out? Or
Yes, thanks.
okay, anything more specific you guys want me to talk about with this? Of course, I'm mentioning this at a high level, but if you do have a question about something specific here, feel free to shout it out.
So with the private string, with that being passed down to the dog class, I know in normal cases they wouldn't be able to do that. Why is it now that it's actually able to be carried down with everything else?
So in typical, I think what you meant by beforehand, it's not able to be accessed outside of the class. But this one, we're not trying to access anything. We're passing down properties into dog. So we're able to access from so it's kind of weird. We're accessing from the child. So the child just has the powers to call to its parents public and protected methods and properties. So private name will actually not be able to be accessed from dog because it's private. But we can still set it using the constructor that's public and get it by using the getter that's public. But you're still right in thinking that name cannot be accessed by dog because it's private. And good call out there.
Does Java let you inherit from more than one?
It does not. It does not. You can only extend one class. So you cannot. So dog cannot extend pet and animal. Great call out. Any other questions?
So is it best to just extend from like the highest level? So if you had, like they had cat, or I guess they had feline and they had cat and tiger and all that, would you just go up to the top and get cat because it should have most of pretty much all the other properties?
Sorry about that. So you're going to want to grab from, okay, so the very tip top, it depends on what you mean by top. The tip top of the hierarchy would be object. Everything stems from object. Below that would be cat, and below that would be tiger. As you work your way down the hierarchy, objects or this classes become more and more specific. So if you want to build something that's a lot like a tiger, then you want to extend from tiger. If you want to build something that's not like tiger but still like cat, then you extend from cat. If it's nothing like tiger or cat, you'd extend from something else. So you extend any object or any class that's closest to what you're trying to build.
So in the real world, what would you do if you needed to extend it past dog?
Can you say that one more time?
In the real world, what would you do if you needed to extend it past dog? Like you can only extend it once, right?
So you can extend pet as many times as you want. You can extend dog as many times as you want. But I can't have dog extend two different classes.
Oh, okay, I understand.
Okay. Yeah. And yeah, that's it, period, sorry. I was trying to think if there's anything extra I want to say on that, but not really. It's you can only extend one class at a time, but this pet class, you can extend it, multiple classes can extend it. So if we want to have a cat can extend pets, parrot can extend pet, etc. and so forth. Great questions, everybody. Anything else? All right. So staying on this dog class, we need to build a constructor because classes need a constructor. The different thing about this is that dog extends pet, and pet has a constructor inside of it. So when that happens, we have to do a new keyword we haven't seen yet called super. You might have seen it because on lecture 3, I accidentally said a bunch of things about this. So hopefully you forgot that like I asked. And today is the first time you've ever seen super. But here it is. Super is how we talk to our parents' constructor, our direct parents' constructor. Anything we pass into these parentheses, we have to act like we're talking to that exact constructor. So I pass in the name here, and that is shoved up to pet to set its constructor. Now take a close look at this. This is very important. This is how our data flow, essentially, between dog and pet are truly working. Any questions about this?
The super name, is that typecasting or no?
No, super is a keyword that we use to communicate only to our parents' constructor. So definitely not anything with casting. Any other questions? All right. So that being said, let's take a quick look at an example. After we define pet and dog here, if I call out to dog, my dog equals new dog, start, I now have access in my dog to call to any of pet's methods. That being said, I can then do my dog.getName. Take a close look at this method. It does not exist in dog, but I can still call to it and no one gets angry because I extended my parent pet, and pet inside of it has getName. This is the true cutting edge fun that we can have with inheritance. So Corey, very good question. Super and extends basically go hand in hand. If you extend a class, and again in this example, pet, and that class that you extended, pet again, has a constructor inside of it, which it does, you need to use the super keyword to call to that constructor. If you don't, then Java will get very angry. So a good way to think about it is if you extend something, chances are you're going to have to use super inside of your constructor. It's not necessarily, don't think of it necessarily as taking place of it, but more of, say, delegating it to the pet class. The pet class is who does this dot name. Remember, the property name and getName exists only within the pet method. But when we extend pet, it gives us access to all of that from its parent. We inherit it. We inherit that access. So it doesn't necessarily take the place. We simply just delegate this dot name equals name out to the pet class by calling to its constructor. So once you pass it in here, it directly goes up to the pet constructor and sets the name inside of the pet class. And if you're having a slight headache right now, thinking about how and conceptualizing this, don't think you're the only one. This is one of the harder concepts. It took me quite a while to wrap my head around exactly how everything's working. So just remember where those arrows go. When you do super, the arrow gets drawn to whatever the parent is, constructor. When you extend a parent class, all of the access of the public methods and the protect methods are now accessible in that child class.
So what happens if we leave super empty?
If you leave super empty in this example, Java will get very angry. It will say that you have not met criteria to extend pet. And that's a great question. So now we'll go into our coding example, and we'll actually see this in work here. So let's go ahead and first just create this fun pet class.
Hey, so with super, how do you know which ancestor you're referring to?
Remember, classes can only extend one parent. So therefore, super can only go to that last parent. So if I extend pet, but pet extends animal, in dog, super still means I'm going back to my pet. It's whatever your parent class is. That's where super sends your data to.
So you're not going to be able to nest supers together as you go further down the line. Is that right?
Nope. Think of them as more of a chain. So your pet class will send data back to the animal class, but your dog class will send data back to the pet class. That was a really terrible way of doing that. Dog goes to pet, pet goes to animal. They pass data back using a single super.
Okay.
Oh, so you can keep on just chaining like the same actual value down to to the child, to different children?
Yes.
For example, like with the name example, if I extend like another child, like let's say like, I don't know, Rottweiler or something like that, could I extend, can I have like a super for that one that would still be the same name? Because it's still, like you said, it's still chaining, right?
Yes.
I don't know if I'm
yes.
describing that like I'm thinking it.
I'm going to try to take that example and see if I can put it in this one just to make sure everything's clear. So we have our pet here, and then we said we're going to create our getter. So public string get name, turn this dot name. All right. What's up, Matt?
I'm kind of surprised you knew that was me. Say in your constructor in your pet class you had more characteristics. Do you need like the super to your constructor? Is that a 1-to-1 ratio, like, or can you like write them all together?
So just like any class, we can keep piling parameters into here. So if we want to do int age, etc., and so forth, we just got to put that into the super.
I understand that, but like say there was like a int ID there, or int, or like a boolean something there, would like there have to be a super name and then on another line be a super int, or can you do super name comma int?
It'd be super name, comma, int, or your ID. So you put commas. We can only ever have one super in a constructor.
So there can only be one super, okay.
Yep. Very good call out. Yeah, great question. All right. So we have our pet here. So any questions about this pet class? It's exactly how our example had it. Because if not, we're going to go up to dog. And we've seen this before. And what we're going to do is we're going to say extends pet. It's just a simple little thing. And now IntelliJ is yelling at us all over the board. So let's see what it's saying. There's no default constructor available in pet. What this means, just breaking it down and reading between the lines, is that we don't have our super defined here. So what it wants is us to put super here and then put a name. Oh, sorry, first name. Excuse me. There we go. And you see how that constructor stopped yelling at us? It's because we put our super there. One more thing I want to call out too is that remember I put the super at the very top. This is standard and IntelliJ will yell at you if you put it anywhere else but the first line. See how it's red here? We need to put it at the very top of our methods, or at the very top of our constructor. Let's do it for the rest of these. Oh. There we go. So what we just did is that we extended dog class on pet and then put in our super here inside of it. So as we can see, we have no get name here in the dog class. But if we go over to my, what did we do, second class, I think? We do it over here and we do dog now. My dog equals new dog. My dog dot get name is now available. This comes directly from the pet class. So now we can access this. Oh yeah, of course I have to put a dog's name. Any questions about this? Oh, get my followers. Why would you have super first name, but the last one you changed to super dog's name? So going back to dog, here I put first name because the dog's first name is in the parameter. So the parameter's name is first name. Dog's name doesn't exist here. While down here, dog's name is in the parameter, so I had to put it into the super, which is the dog's name. So I have to make sure I'm following according to how my variables are named in this. There was also a question asked, what if we didn't put anything into the super? Well, we're still getting that error. It says expected one argument, but found 0. So Java is going to get a little testy if we do that. By little testy, I mean really testy. Java has like 2 settings, like really testy or like happy, kind of happy.
Now, what about the, okay, in the pet class, you had name in a constructor. Now you have first name and dog's name.
And this one right here?
Yeah. Well, or I mean, in the super.
In the super, I have dog's name, right?
Okay, but in the parent class, you just have name.
Remember, this is just a name of the variable. It has no connection, has no connection to the other constructors. Just like when you're passing something into methods, you can name everything differently. Just making sure your data types stay the same as it flows through your application.
Why do you need super first name but not last name or dog's age and other parameters?
Because remember that super goes directly to our parent class. Our parent class is what? Pet. Very good. So super goes to our pets constructor. What does the pets constructor take?
A name?
Very good. So looking at dog, we only have to pass in a name in here. Remember, super talks directly to our parent class. Pet is the parent class.
Okay. Thank you.
Absolutely.
So
if anyone,
if you had, so I'm
Yeah.
sorry.
No, it's okay. Go ahead.
Okay, so you're saying if you had 2 or 3 perimeters in your pet class, the public pet method, or the parameters, then you would put two perimeters in the super.
Absolutely. So there we go. I just put an ID. And now you know who's going to be very mad at me? The dog class is going to be really mad at me. See how everything's lighting up here? So just make an ID for it. All they're going to have is an ID of 1. So I put 1 in here. Why am I putting 1 in here directly? Well, I don't have a parameter up here that takes in an ID. So I'm just going to put 1 in there. If I wanted to, for whatever reason, I could put in int ID and then pass in ID down here. But in the end, to answer your question, you just pile it in the super if you want to pass that data to the constructor of pet.
What if we've overloaded our constructors in the parent class? How do we
That's a
handle
great
that
question.
with super?
Just like how it's handled out in the normal program as well. The behavior doesn't change as much. You can still overload your pet here. So if I come back over to dog, now I can get rid of 1 because I don't want an ID in there. I gotta get rid of the comma. So you can still overload your constructor, which technically overloads your supers.
Cool. Thank you.
Yeah, absolutely. All right, anything else?
I have a quick question.
Yeah.
So I'm struggling to understand the purpose of super. So on line 15, does it set the name? And if it does, how is that any different from what's happening on line 16?
The first question, yes, it's exactly what's happening. It's setting the name in the pet class. How does it differ from line 16? Absolutely nothing. This was just an example. Technically, the dog can now have access to its own name from 2 different methods, which is pretty useless. But this is just an example.
Okay, gotcha. Thank you.
Absolutely. So now if I wanted to call that out, I could take out my dog's name here because I no longer need it because it's now managed by the pet class. So what I do here is if I want to get my dog's name, this dot name. Remember, name is not accessible because it's private in the pet class. So what do I have to do is say this dot get name. So now I can access that name that's stored in the pet class through this method. And also change this one too. This dot get name. Anybody's head hurt yet?
Hi. Mine does.
Perfect. And I'm doing my job. So we can use inheritance whenever and wherever we can. Yeah, absolutely. When we master the understanding of why we use inheritance and where the best place to use it whenever you can. It does save you a lot of time on your code. Because if you have to program for 1,000 pets and you just have one method in each one of them, that is 1,000 copy and pastes. That is just a pain. Might as well just throw it in a pet class and have everything else extended. All right, we're gonna move on. Feel free to keep throwing out questions and we'll go back if we have to. All right, I think, oh, and then that and that, okay. Okay, moving on. So we're gonna take that code that we had in the previous example and just paste it in a little bit different way. Excuse me. So let's get a little bit deeper in inheritance. You said your head hurts. Well, get ready. Everybody strap up. Let's talk about if we wanted to have our pet make a noise. Now, hardest question of the night. Does a cat and a dog make the same noise?
No.
Very good. A+ is across the board. It does not. A cat meows and a dog barks. So when we are trying to define a method in our parent class, when our children don't have the same way they want to write those methods, we come to a little bit of a conundrum. I know both of my children need this method, but I can't provide the correct way to write for both of them. My cat meows, my dog barks. What are my children doing? Like, are they even my children? They don't act the same. So what we do is we write a certain type of method by saying public, abstract, void, make noise. This forces all of our future children, our cat and our dog, to define their own make noise method. How we did this magic is that we said abstract here, public, abstract, void. This tells all of my future children, you need to write this method for yourself because I don't know how to write it, but I know you need it. One more thing to point out also is that we have a semicolon at the very end. So how would we start defining this then in our dog class? Well, that's a great question. What we need to do is start with public, and then we say void, make noise. We just copy over that method name. But what we left out here was abstract. We didn't put abstract in here. We say public, void, make noise. One more thing we really need here is then an annotation that says @ override. As we remember from our previous lectures, this is what tells our compiler we want to customize this method to however I want my dog to make a sound. In this case, I want it to bark. But but we cannot forget the annotation @ override. So let's see this in code. We're going to come down here. We're going to create that public. What's the next word after public that I put down here to make it one of these special methods?
Abstract.
Very good. Void and then make noise is what I wanted to do. Make noise. That's not using noise. And then what do I put at the end of an abstract method?
Semicolon?
Semicolon.
Semicolon. Very good. Public abstract. Why am I? Oh, crud it in half. Oh gosh. I am getting ahead of myself. Dang it, I put this size in the wrong place.
Does the class need to be abstract?
It does, yes. It's like, why is this out of order? Yes. What we have to do up here is put abstract. I know we haven't gone over this yet. We're going to get to it in the lecture, I promise. But just note that we put abstract up here in the very top. And now we have make sound down here that's also abstract. Abstract methods can only go inside of abstract classes. I just got ahead of myself there. I do apologize. So we say we have one related problem. So let's go ahead and look at that. It says that class dog must either be declared abstract or implement the abstract method, make sound. Reading between the lines here, what it's saying is that dog has an abstract method that we haven't customized yet. We haven't implemented it here. So we're going to get yelled at by Java. So what we need to do is implement that. If I say public void make sound, what do I need to add to this? What am I missing here?
Method.
Override.
String. Abstract.
I heard @ override. We need to put the override here once we're trying to override or customize our abstract method. That's one big thing. Don't forget our annotations. If we want to customize that abstract method, we need to make sure we override it in the child class. And I'm going to make it bark. So that's
okay. So I got a question.
Yes.
All right. So if you have to define what make sound is anyway, then like, why don't you just like create a new method in each class instead of just making the original class abstract and then extending it? You know what I'm saying? Like, why don't you just like on line 44? Why don't you just make its own? Like every child just have its own method to do what you want it to do.
Yeah, great question. So first thing is that if I make a pet and I trust my fellow developer to implement that make sound method on top of 100 other methods that need to be in that class, well, we're putting a lot of trust in the developer, and we can easily get the human element there to forget after the 100th pet to do the make sound method. The abstract method forces the developer to make it. They're forcing you. Furthermore,
okay, that makes sense.
So that's one thing. And furthermore, and we'll see this later, is that if you do it as an abstract on the pet class, when we're dealing with cats and dogs, we can deal with them in their general sense. We can deal with them at the pet level. This is gonna be hard to vocalize, but if we're dealing with them at the pet level, we can call to the general pet.makeNoise. We don't need to know if it's a cat or a dog. We can just call make noise on the abstract class data type when we're dealing with it in code. I don't expect you to like understand what I just said because I just spoke that, but
no, that just makes sense.
Okay.
Doesn't it fall upon the polymorphism as well?
Exactly, yeah, and we'll get there a little bit more. As we build upon our knowledge of inheritance, it'll become more apparent of why we would want that. Yeah, so that is. Oh, then we'd say my dog make noise, make sound, and there we go. Let's make sure we can run this. I don't even know what I'm running. Okay, second class. Perfect, and then we get bark back. A-okay. Just a reminder, do remember that we put abstract here in this pet class to make the abstract method. All right, let's move on just a bit more. Take a quick step back and just go over what we've been doing. Answering this question, if I wanted to bring in all the properties and methods from a vehicle class, what would I put here in this code to finish it?
Static.
Extends.
No, oh, extend, sorry, extend.
Very good, extends. If I wanted to customize my honk method in the car class inherited from the vehicle class, what would I put above it?
Override.
Override.
Very good. If I wanted to use a toString method on a whole number, what would my data type have to be in this parameter?
Integer.
Integer.
With a lowercase or capital I?
The object integer.
Very good, the object integer. Awesome. Remember, we can't use a primitive in this one. All right. So moving forward, let's talk about what we were talking about with inheritance and everything. So if I ask you, what kind of pet do you have? The typical reply from somebody would be, I have a dog or a cat, or whatever other kind of pet you have. But what you would not answer if I asked you if I have a pet is, you wouldn't say, I have a pet. No one says, what pet do you have? You don't say, I have a pet, because pet is a very general term for dogs and cats. Pet can mean both dog and cat, and they share similar characteristics. They both can be housebroken. They're both lovable at sometimes. They share a lot of characteristics. So pet is the general term for dog and cat. So breaking that down, it's also a general class type that includes how we build more specific types, as we've seen in our past examples. Those more specific types being dog and cat. When we have this very general class out in the world, no one can create a pet. You can't go to the pet store and buy a pet. You go to the pet store to buy a dog, a certain type of dog. You go to the pet store to buy a fish. You don't go there and walk out with technically a pet. This pet is a label. It's just a label on top of something more specific: a dog, a cat, a fish, a parrot. When we deal with these more general labels, when we deal with these more general classes, this is a huge indicator that something is abstract. It's a general outline of what something that will be more specific down the line. So this is an indicator of how something would be abstract. Looking abstract a little deeper, we're going to build an abstract class now. Like I said, my slides were a little bit out of order, but we're going to deal with it. To start building that abstract class, we say public, and then what would be the next word? Anybody know what the next word is to build an abstract class?
Abstract.
Very good. Abstract, and then the name of the class. So we have pet here. Inside of it, nothing changes. It's still private string name. It's still public pet, this dot name. Nothing here changes. So the question you might be asking, or have been the entire time of this lecture, is why are we doing this? Why do we create abstract classes to begin with? Why do I have to sit through Kyle talking about this the whole time? Well, the answer is, if we wanted to define pet, once we've declared it as abstract and we set it to Stark, if we tried to do this in IntelliJ or in Java, we would get a lot of errors. Abstract classes cannot have an instance created from them. This is a very, very important thing to note when you're creating Java, is that if you create an abstract class, it is there as a rudimentary outline of how something more specific is going to look. Pet is there to define what a dog and a cat are going to look like, not to have an instance created of itself. So let's take a closer look at this. As we know, we already created the abstract pet here. So that means that dog extends an abstract class. So if we come over to second class and we try to create pet, you would immediately start getting red here. Cannot resolve the symbol pet. Because pet has, well, I can import it. So we cannot create a brand new instance of the pet. It will just start complaining. So any questions about this? Any concerns? Okay. So this is the biggest thing of why we do abstract. If you're asking yourself, why would I ever create anything abstract just in case I need it? Well, this is again to limit ourselves of making either mistakes, because we don't want to, for whatever reason, introduce a pet instance into our code because it would break it. Saves us from ourselves. And then we have definitely some polymorphism and other small things that we're going to learn about in future lectures that really, really help us out. So when you can identify when something should be abstract, first play around with it, but if it can be abstract, make it abstract, and make those more specific classes the things you actually work with in your application. All right, how are we doing on time here? Cool, cool. All right, so on to this one, true or false. An abstract method cannot be defined in a child class.
True.
False.
Uh-oh, we got a controversy. Is it true or false? An abstract method cannot be defined in a child class.
False.
True. With at override notation, we can.
Very good. Not only can it, it must be defined in the child class. Remember that if it's an abstract class that has an abstract method in it, in order for that child class to work, we must override it. We must customize it to how we want. It's a demand by our parent. The next one, an instance cannot be created from an abstract class.
True.
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 Awesome. It is true. You can only extend one class.
False. Well, true.
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 I'm hearing 50-50. This one is true. You can only extend one class. But remember, one class can be extended multiple times. Multiple classes can extend the pet class, but a class can't extend the pet class and the animal class, for an example. So you can only extend one class. The movie Sandlot was released in 1993.
I don't know her.
Killing me.
That was forever ago.
True.
Cats are cute.
Nice.
True.
Fun fact, that's my birth year, so I found that out today. So I was like, oh wow, that was released. I was like, that was released forever ago. And someone was like, you know, that was released like 1993. It's like, oh God, I'm old. So it is true. April 7th, 1993. All right. Everybody ready? Everybody take a deep breath. Almost to the end. How's everybody feeling? Everybody okay? Everybody good? So happy? Remember, Friday's almost around, almost here. Okay. All right. Let's get into casting. Before we do that, though, let's visit one of its relatives, or something that's very similar. Something you might have heard of is parsing. Everybody remember parsing? Yes, no, maybe so?
Yes.
Right, parsing. Parsing would be if we have a string, a number as a string, that's 8. And then we put it through a parser. So integer dot parse int, so we have his number as a string. And then we get back a number. Magic, right? That magic was through parse int there. Another example would be if we want to get back a double, we do parse double, and that number is a string, so it would come back as a double. Great, everything looks A-okay. What's happening here is that a value is being converted into another data type, a value. So that 8, that's a string, is being converted into an integer 8. We're parsing it. Now let's talk about its very close relative, casting. Casting converts a class into another class type. Let's look at this example. Pet equals new pet, or pet equals new dog Stark. Are you asking yourself right now, is this possible? Because it absolutely is. This is kind of where it gets weird. What happens is that right now on the right-hand side of the equal sign, we have a more specific class, the dog class. We're creating a new instance of it, and we're saving it into a more general data type, the pet class. We can go down in hierarchy. So we go from more specific to less specific. Anybody angry about this with me? Never gonna trust me
Can
again?
you explain it a little bit more, please?
For sure. So think of, so we know our pet has 2 children, cat and dog. So what we can do is that we can save our objects, our dogs, in its more general parent data type. We can save things in its more general type, even though it's abstract. Remember, abstract just means that we can't create a new instance of it. never means that we can't utilize that data type. So what do we mean by that? I said pet equals new pet. This is not allowed. But what we can do is add the dog to it. So now inside of here in this pet is actually technically a dog object. So if we did system.out.println pet.getName, and we run this, technically we should get start back. And we do. That's because we wrapped it in our parents' data type. So any of our parents' methods are still accessible. So if we want to do pet now makes sound, technically we know it's a dog object, so it should bark. So this still works as well. So this is the magic of inheritance. So I hope anyone's headache isn't getting a little bit worse. But this is how we can utilize our parent class data type to save our more specific child types, like dog and cat. Now, we were talking about casting here. So let's talk about casting this pet into a dog. Anybody know how to do this? Anybody know how to start us off?
It would be, well, isn't it right there? Like pet equals new dog?
Well, if we wanted to cast pet into a dog, how we would start with is we need to create a dog variable to capture the dog. So we say dog equals, and then the next thing we would do is that we would wrap the class type that we want to cast it to in parentheses, and then put the variable next to it we want to cast to the dog. So we'd say dog in parentheses with pet. What it's doing is taking that Harry Potter magic, waving its beautiful little wand, and transforming it into a dog class. Any questions?
Okay, I'm sorry, wait, that first example, pet equals new dog start, like, what is that called? If that's not casting?
The first example is not casting. No, instead we're saving to a more generic data type. So we're just essentially we're just defining a variable here.
Okay.
So we can go up in hierarchy pretty easily. So we can go from dog to pet pretty simply. We just do that first line there. It's coming from pet to dog that's a little bit more complex. That's when we have to cast something.
Okay.
And can you only do this within hierarchies? Inheritance?
Yes, for the most part, casting you want to do with things that are inherited from each other.
Okay.
So yes, typically casting is used for when you want to convert one class to another class that are somehow related to each other. What do I mean by related to each other? They're somehow in a hierarchy, like we've been looking at today.
Can you give an example as to why we would need to?
Why would we want to do this?
Yes.
That's a great question. Why would we want to do this? Well, the first thing I can remember when you were really mad at me about 2 lectures ago, and now you're probably just as mad? Well, remember that equals method? And we had that Boolean equals object obj in there? And if we remember our equals method, we go down to it. We did this magical little thing right here to convert our object into a dog. Does everyone remember this kind of? Unless they blocked it out of their memories.
Yes.
This was our first magical experience with casting. We casted an object into a dog. So you might be asking yourself, well, we had to cast this object in order to do something. That was the equals. But you might be asking yourself, okay, object. So let's take one more deep breath Let it out, no swear words. Let's take a look at object. Why do we always take an object and equal sign? It's because in our family tree, we have to start from somewhere. We all have a great, great ancestor that we all started from. It all stems from somewhere, and in Java, it all stems from object. Every class somehow stems from object. No matter where it comes from, what you're doing, we are stemming always from object. So dog, cat, animal, pet, they all come from object. So why we put object in that equal sign is so we can take in anything and try to convert it into dog or whatever we're trying to do that equal sign to. So if that doesn't answer your question, let me know and I can go into a little bit more detail. Or if anybody wants me to go into more detail in general, just let me know and we can do some more things about that. When it's quiet, that's really concerns me. Curtis, how are you feeling about it?
I just need to see it happen.
What do you need to see happen?
See it in action.
See it in action, okay.
Yeah, like I get the concept, but I don't understand yet why and when I would do it.
For sure, okay. Well, you will see inheritance here in the next few studios / assignments, but just for our sanity's sake, over here, let's just do that example. We wanted to create a pet and we want to convert it back into a dog. How do we convert this back into a dog? Someone remind me. We want to convert pet back into a dog. What do we put here on the other side of the equal sign?
Parentheses dog.
Oh.
Yes.
Pet. Very good. Awesome. So now we just converted it back into a dog. So we converted as, or we set it up as a pet, but we converted it back into a dog. Why would we set it as a dog now? Why didn't we just leave it as a pet? Well, that's because if it was set as a pet, or if it's set as a dog, I get access to all of dog's methods. So dog has bark, it has get my dog's name, things like that, right? So we have bark. Let's just say bark. If I do pet up here and I just leave it as pet, I type in bark, it's not here. That's because pet right now is a pet, and bark doesn't exist on pet, it exists on dog. But as we can see, we casted it to a dog, so now we have access to it. Now, to answer your question, how would you use this in the real world? Well, I do not have a good example for that just yet, but I promise you will find one. I promise you will find one. So let's, with the last few minutes I have here, what if I extended pet on this one? How angry would it get? What? I'm gonna take out name here. Okay, so I took out name here. What am I gonna put in place? Someone help me out here. We're converting cat to a pet. What do I put here?
Super.
Super.
Very good. What do I pass in the super?
Name.
Very good. Name. All right, let's do it down here too. We're just gonna copy that. Paste it. I'm gonna paste it here too.
How many parameters can you pass into super?
As many as our little heart's desire. It's as many as your constructor in your parent class has. What's the limitation of how many constructor, or of how many parameters can go in a constructor? I don't actually know. That's a really good question. But to answer super, as far as I know, I've never gotten to the limit, but you can put in quite a bit. Was that a trick question? Do you know the limit? Because that'd be really cool.
No, I don't think it's a limit. I think like you was just saying this. How many?
Okay. No, I was thinking it was if you knew the limit. I was like, I thought it was a trick question. It's like, tell me, like blow my mind. All right, so we have get name. Awesome. Okay, so we converted this. Uh-oh. Oh yeah. Why is it still red? Anybody got it? Why is it still red? What are we missing here? Super bonus brownie points for whoever can tell me what we're missing in
Make
the stat
noise.
box.
Good, good, good.
Awesome.
Make sounds or make noise.
Heck
Like your real
yeah.
brownies.
I don't know how to bake, and honestly, for your health and safety, I would not want to bake you brownies. I'm sorry.
Is it
But
a
I guess
semicolon?
What is it?
Was it a semicolon?
What we're missing? Oh no, it is the public void make sound method. And so what do we need on here to finish up our issue? What do we need to put?
Override.
Override.
At sign override. Awesome job. And what sound does a cat make?
Moo.
Moo.
Oh, my
Very
bad.
good. All right. So our cat goes moo whenever it makes a sound. So what we're going to do is now go back to second class. And we're going to create now a cat. Where's it go? I forgot if we've taken any other parameters there. Let me import this class real quick. There we go. We have two pets now. We have the cat and the dog. Comment out that, comment out that, comment out that, comment out that. Okay, so now we have two pets here. So what's going to happen, do you think, if I come down here and I try to cast the cat? Do you think the world's going to blow up? Anybody? Anybody got a hypothesis? We're gonna run it. Everyone, fingers crossed. Oh no, we get an exception back. A class cast exception. If you see a class cast exception, that means we're casting our general class, the pet class, to the wrong specific type of class. I try to cast a cat to a dog. Therefore, this thing's gonna break. So just a call out, if you see this error, class cast exception, this is the issue. We always want to make sure we're casting our dogs to dogs. So any other further example you guys would want to see with what we have here with setting those general classes as dogs, as cats, and casting back and forth? Any specific examples here? Anything that would make you all a little bit happier before you go into your studios?
Hey, so just as a general rule, like when you're casting something, like the object that you're creating is going to be the same as whatever's in that parentheses when you're casting, right?
Exactly. Yep. This and this should definitely line up.
And that's like a general rule of thumb.
Well, technically, if you really wanted to, it is a rule of thumb, but technically you could cast this dog back into a pet. So you can cast to a dog and then put it into its general class again. You can do this. Do you want to do this?
It's not going to happen in the real world.
No,
though, right?
not usually in the real world. If you want to cast it to something, make sure it's the same type.
Okay.
But remember, you can always go up in hierarchy. But yeah, great question. Great call out. Well, if that is everybody's question. I was very bored during a staff meeting today, so I definitely got way too into this, but we are finished. So any final questions, comments, concerns?
Yes, I have one question.
Yeah, what's up, Hal?
Okay, so in our class, can we use more than one super keyword like you used in just last class in the constructor?
So one super per constructor, but every constructor needs to have a super.
Oh, okay. And can can the child constructor have more parameter than the parent constructor?
Sorry, say that one more time.
Yeah.
Okay, can a child constructor have more parameter than a parent?
Absolutely. As we can see here in this example, we're taking in 3 parameters in our constructor, but only passing our super 1.
And its first parameter should be the same as as parents, like
Not
the here.
necessarily. Not
Okay.
necessarily. We can pass in last name here too if you wanted to.
No, I mean the value type, like a string or integer. Like if you put in parents, so the parent is having a string in the first parameter, and the child is having integer in the first parameter. So does that work? Or it should be string and string?
Nope, we can absolutely put int first. You just have to make sure that you're passing in that exact way when you're calling to the super. So we see we have int ID here and then the name. So if we come back to dog, we'd have to switch that out. So we can put 1 here first and then first name. You just have to make sure it matches up with your parents' constructor, how they call it.
Oh, so it should be specified in super, but not in the parameter. Like I can do string first, I mean integer first and then string, or I can just reverse it as string and then.
Yeah, absolutely.
Integer.
However you want to set these up is completely fine in the child class. Remember, when you pass things to super, super just exactly means going over to the pet class, exactly how this constructor has it set up.
Okay.
So you have to pass in that data exactly how these constructors want into the super.
Okay, got it. Thank you.
All right, any final questions, anybody?
No, but I was reading somewhere that it's typically 7 parameters that people think you should max out in constructors. That isn't the max necessarily, but it is for like check style, I guess.
And I completely agree with them. If you're passing more than 7 constructors, that is a hefty class that you're defining. So it would need to be revisited. So no, I agree with that. 7 sounds like a good number.
And methods are limited to like a length of 255. So I don't know if that applies to.
That's a pretty big method too. I would also want to revisit that method if I had 255, but I'll take it. Thank you for looking that up.
Well, I have one more question, sorry.
Yeah, go ahead. What's up?
Okay, so in the book it is discussed that it was I don't remember right now exactly, but there was a runtime error, like if you caused something wrongly, or you are going to receive a runtime error.
If you do what incorrectly?
Like the casting.
Right, exactly. So we took a look at that. So down here, if you cast something incorrectly, say I wanted to cast a cat into a dog, what would happen if we ran this is that we would get a casting exception, a class casting exception. So that is, if you see that exception, that means something's being casted to the wrong specific type. Jeremy, thank you very much for that too. You can apparently have up to 65,535 constructors in a class. Interesting. God
So what
forbid any
it specifically means, like that dog doesn't have cat?
So
or they are
remember
not equal?
Remember our hierarchy, that dogs, let's go all the way to it. Pets is defined from dog and cat. So you can't cast dog into cat. You can't cast cat into dog. They're not parent-child related. They're both children of the same parent. So no. The main reason for that specifically is that the methods inside of cat could differ from the methods inside of dogs. Therefore, Java has no idea what to do there. So they differ in the end, they differ too greatly to cast into each other. So Java says no.
Oh, okay. Thank you.
Yeah, absolutely. All right. Anybody else? Otherwise, thank you again for putting up with me today. You all have been fantastic. Let me get to the end here.
Thanks,
I
Kyle.
hope absolutely. I hope everyone enjoyed Inheritance. Take another close look at it tonight in the studio. Enjoy it. Get your hands dirty with it. And in the end, it does make our applications more powerful. So I really hope you do grow to like it someday. Maybe not tonight, maybe not the near future, but someday, hopefully you'll grow to like it. Other than that, everyone stay happy, stay healthy, stay happy this upcoming weekend, and stay out of the cold and out of the snow if you can. Unless you're going sledding, then go for it. Other than that, I'll let you guys go to your breakout rooms. Have a great weekend. And yeah.
Thank you.
All right. Bye, everybody.
Have a good one. Have a good weekend.
You too.
And everybody.
Night, everyone.